So the first thing is something we talked about. You just had it on your last test, the fundamental theorem of calculus, right? Fundamental theorem, we've seen that before. It's this thing, right? When we have bounds. When we have bounds, how do we do it? Well, you find the antiderivative, and then you plug in the top bound, you plug in the bottom bound, and then you subtract, right? That is the fundamental theorem. That's part one. It's called the evaluation part. That's what you were tested on last chapter. There's a second part, though. There's a second part to it that we didn't talk about last chapter because I wanted to leave it for this chapter. It deals more with graphing, deals more with graphs. This one is evaluation. Find the antiderivative, plug it in, do the same thing, subtract, you get your answer, right? The second part deals with the idea of, it deals with two things. It deals with derivatives and antiderivatives, integration. It kind of brings them together. You can see on here, you can see derivatives, the first two, okay? So before I show you what it is, let's try this guy. Let's do example number one. Okay, so example number one says find the area under the curve 2 to x for g prime. So when we're finding this guy, what's the first thing we always do when we're finding area under the curve? Antiderivative, right? So what would the antiderivative be for g prime? G, right? Okay, so let's write this down. So the antiderivative would be g of t, right? And then we would have to evaluate from this to this, right? Whatever the top bound is minus the bottom bound, right? And then we plug in, right? G of x minus g of 2, right? That's as far as we can go because we don't know what g is. So that's as far as we can go on that one, right? Okay, so now let's look at this guy. What's the difference between this guy and the guy we just did? This guy right here, right? This blue part right here. That wasn't there before, right? What does that mean to do? When you see that blue part, d over dx, what does that mean that you have to do? It's an action. What action do we need to take? We haven't seen it in a while, but you've seen it. You've seen it. You saw all last semester. It means find derivative, right? So do what you just did, but then find the derivative of it. Okay? So what was the answer we just got? The answer we just got was g of x minus g of 2, right? That's the answer we just got because the inside is the same as what we just saw. Now what this is asking to do is find the derivative of that. Okay? So I'm going to find the derivative of g of x, and then I'm going to find the derivative, not d, of g of 2. Okay? So let's do this one part at a time. What's the derivative of g of x? G prime. Minus. So this guy goes here, and that guy goes there. What's the derivative of g of 2? This could be a little tricky. What's the derivative of g of 2? It's not hard, but it might be a little tricky. Why 0? You're right. Why is the derivative for g of 2 0?
Because the derivative of g of 2 is g of 2 times 0, the derivative of the inside.
Exactly right. What's the derivative of this? That's all it is, right? Plug in 2. If I plug in 2 to g, wouldn't I get a number, right? When I plug in 2 to a function, don't I get a y value? Isn't that how we get a y value? And the y value is always a number. What's the derivative of any number, any value? 0. Right? So our finished answer was g prime. So what I want you to do is go back to number 1. Look at number 1. Where did we start and where did we finish? Started here, right? Finished here. How can I go from here to here without having to do all that middle stuff? What did I essentially just do to that guy to the left to make the right? I did all that. That's all the middle stuff, right? But let's say I wanted to skip all that. Let's say I just wanted to go from the first circle to the next circle. All I did was take this value and put it in there. And that would give me g prime of x, right? Isn't that what I finished with after example 2? So the second fundamental theorem, or part 2 of the fundamental theorem, says anytime you have this relationship, so anytime you're taking the derivative of an antiderivative, you're just going to end up with this guy right here. That guy right there. Okay? So anytime you're taking the derivative of an antiderivative, why does that work? Because you're just doing the opposite. I'm taking 2 steps forward and then 2 steps back. What do I end up with? Just this guy. Right? You're undoing it. You're undoing it. I'm finding the antiderivative and then find the derivative. Just end up back at f of x. Okay? So let's take a look at this guy here, number 3. So let's do number 3. Let's say we didn't know any of this. Let's do number 3 the longer way. Okay. So g of x is the same thing as this guy here. Find g prime. So in other words, they want us to do this. Find the derivative of this guy. That looks like the problem we just saw for number 2. Right? That's what g prime is equal to. Well, let's do it the long way. In math, we do the inside first. Right? So the antiderivative for f of t is capital F of t. And then we're going to evaluate from x to negative 2. Okay, so now I got to plug in x. F is the capital F is the antiderivative of f. That's why I used a capital instead of a lowercase. Okay, so plug in. Oops. Plug in x minus plug in negative 2. Okay. Now I got to find the derivative of each. Okay. So the derivative of capital F of x minus the derivative of capital F of negative 2. So what is the derivative of capital F of x? If the antiderivative of lowercase f is capital F, what is the derivative of capital F? Lowercase f, yep. And then the derivative of that would be f prime, remember? What is the derivative of f of 2? Negative 2. 0, because it's a value, right? It's a y value. If I plug in negative 2, I'm going to get a y value. The derivative of any value is always going to be 0. So in the end, you just get f of x, right? Now, I could have skipped all of this by just saying, hey, can I just plug in this value in here? And I would have been done. That's what the second fundamental theorem, or the second part of the fundamental theorem, says. You can skip all that. Just put the x in there. That's what it is. That's the derivative of the antiderivative. Okay? Okay, so number 4 actually gives us some stuff to play with. Number 4 actually gives us an actual function. So let's do it. So let's do it to show. I bet you this is what I'm going to end up with. 5x to the third minus 4x plus 1. I bet you that's what we're going to end up with. Because all I did to do that was I moved this guy here and this guy here. But let's see. Let's do it the long way. Okay. First thing to do, parentheses. Find the antiderivative of that guy. Okay, so the antiderivative of 5t to the third is 5t to the fourth divided by 4. Minus the derivative of 4t is 4t squared divided by 2. And then the derivative of 1 is just t. And then I have to evaluate it from x to 3. Okay. So I get 5/4 t squared, or t to the fourth, minus 2t squared. I'm just cleaning it up a little bit. I'm not doing anything significant. Just rewriting it. So the fundamental theorem, which we've done before, says plug in the top, plug in the bottom, evaluate. Okay, so I'm going to plug in the top. So the first one is x. So I'm going to plug in x everywhere I see a t. So 5/4 x to the fourth minus 2x squared plus x minus, now I'm going to plug in 3. 5/4 3 to the fourth minus 2 3 squared plus 3. Okay, so the first guy is just 5/4 x to the fourth minus 2x squared plus x. The second guy, let's see, 81 times, 81, 3 to the fourth is 81 times 5 to the fourth, so 5/4 times 81 minus 2 times 9, which is 18, plus 3. Now, this guy is going to give me a value. Fraction, probably a fraction, but it's going to give me a value. After I do this, what's my next step going to be? Derivative, right? And what's the derivative of all that stuff in red going to be? 0. So this is kind of meaningless. It's just going to be 0 when I do the derivative. So now I'm going to do the derivative for this part over here. So the derivative is 5x to the third minus 4x plus 1. Which is exactly what I thought from the very beginning it would be. So this process that we've done for 1 through 4, you're not going to have to do very much at all. This is not the big part. The big part is understanding what it says. All it's saying is the derivative of the antiderivative is whatever value it is. That's all the second part of the fundamental theorem says. Now, where are you going to have to use this a lot? Example number 5. When you're looking at a graph. So the first thing we did, or not first thing, one of the things that we did, one of the big things that we did last semester was reading graphs using derivatives. We asked questions like, where is the function increasing and decreasing? Where is the function concave up, concave down? Where are the critical values? Where are the point of inflection? We asked all of those questions last semester, right? When we were talking about derivatives, guess what? It's coming back. We're going to do that again. We're not there yet, but that's what we're getting, okay, with this. Okay, so this question says, now that we've established how to take a derivative of an integral, let's look closely at what it means to define a function as an integral. Okay, so g of x is equal to the antiderivative there. This graph is w. Okay, so g of x is equal to the integral. This graph over here isn't g of x. This graph is a graph of w of t. So how are w and g related? Because that's going to help us answer these questions here. How are w and g related? G is what? The opposite, yeah. The integral, the antiderivative, right? What does that mean? When I say integrate or find the antiderivative, what is that process asking you to do? It's asking you to find the what? Not area under the curve. Area under the curve. That's essentially what it's asking you. G of 0 says find area under the curve. So how do I figure it out? I'm going to plug in 0. Everywhere I see an x, I'm going to plug in a 0. So g of 0 equals the integral from 0 to negative 2 for w of t. So to figure out what g of 0 is, I have to figure out what this integral is equal to. And we've seen this before. You're just finding area under the curve from negative 2 to 0. You did that on your test. You did that on last chapter. So let's go to the graph. What is the area under the curve from negative 2? So let's see. Negative 2 is here. 0 is here. So the area under the curve would be here and here. That's what it's asking you to do. Find the area of those two triangles. Okay? So let's see. The first triangle is a 1 by 1 triangle. So 1 by 1 is, so 1 times 1 is 1, divided by 2, because it's a triangle, I get 0.5. Same thing over here. But one of them is negative, right? So it's positive 0.5 minus 0.5. So the area under the curve is 0. Okay. So let's do the next one. G of 2. So I'm going to plug in 2 everywhere I see an x. G of 2. So I see negative 2, 2, W of t. I should put a dt. So G of 2 is now area under the curve from negative 2 to positive 2. So the area that we just found plus a little more. Use a different color. I'm going to use yellow. Okay. So I got to find the area of the pink, the blue, and the yellow now. Well, I know what the area of the pink and the blue are. It's 0. Together, it's 0. I just have to find the area of the yellow. Well, it's kind of a house-looking thing. So a house is just 2 trapezoids together. They're the same size trapezoid. So if I find the area of one trapezoid, I can just add them together. So base 1 is 1. Base 2 is 2. So if I add those together, I get 3. So 3 times the height. The height is 1. So 3 times 1 is, it's 3 divided by 2. Last thing is divided by 2. So it's 3/2 or 1.5. Okay. So now I'm going to add 1.5 to what I had before. Or sorry, 3. Sorry, I'm going to add 1.5 plus 1.5, which is 3. And you get area is 3. Okay, letter C. This is where it gets interesting. So 3 of negative 3, G of negative 3, negative 2 to negative 3, W of t dt. So I have to go from negative 2 to negative 3. What's the problem with going from negative 2 to negative 3? I can't go left, right? I can only go right. So, thanks. So, what I have to do is switch the bounds, right? Thanks. I have to switch the bounds. So to do that, you just flip-flop them. But you need a negative in front, or a negative 1 in front. A negative or a negative 1, whatever you want to think about it. So now I can do it. So now it's from negative 3 to negative 2. Which is this orange part here. So again, it's a trapezoid. Base 1 is 2. Base 2 is 1, so I add them together, I get 3. Times the height, which is 1, so 3 times 1 is 3. Divided by 2, you're going to get 1.5. But it's negative since it's negative, since it's below, just like this guy was, right? It's negative. So I get that. The area is negative 1.5 since it's underneath the x-axis, right? But then I have to multiply it times the negative 1 that I had for flipping the bounds, right? So now the area is going to be positive 1.5. So it gets a little tricky there. Not too bad, but when you have to flip the bounds. Okay. Okay. All right. So before we get to see, here's the increasing, decreasing, concave up, concave down, maximum, minimums, all those questions that I told you about. Let's fill out the table first. Let's fill out the table. So we have a new graph. The graph is f of t. Okay. Graph of f of t. The table is g of t. They're not the same, but they're related. How are they related? How are f and g related? G is the antiderivative. G is the area, right? G is the area under the curve for that graph. We call it accumulation. It's the accumulation of the graph. Okay? So we got to fill it out. Okay, so 3. So first thing I'm going to do is I'm going to plug in 3 for x. Sorry, negative 3. Oops, not f of x, f of t. That's the first thing I'm going to do because I got to figure out that. So from negative 1 to negative 3. Is that a problem? Yeah, going the wrong way, right? So I got to flip them. So it's going to be negative 1 times negative 3 to negative 1 f of t. So negative 3 to negative 1. Negative 3 to negative 1. Here's negative 3. Here's negative 1. One part is above the x-axis. One part is below the x-axis. Looks like 2 triangles. The triangles look like they're exactly the same size. Let's see. 1 by 2, 1 by 2. Yeah, it looks like they're exactly the same size. So if I was to add them together, they'd just cancel out, right? 0. Now each of them are 1. 1 times 2 divided by 2. So each of them are 1. So this is 1. This is negative 1. But again, they would cancel each other out. So now I'm going to do the same thing, but for negative 2. Do I still have to flip the bounds for this guy? Yeah, I do, right? Can't go left. Negative 1, can't go left. I can only go right when I'm trying to find area into the curve. So I got to flip the bounds one more time. So negative 1 times, and then I would flip it. So the area from negative 2 to negative 1 is the triangle below the x-axis, right? The triangle below the x-axis, this guy right here. So the area is negative 1, but I also have to multiply it times that negative 1 that was already there, right? So when I do that, I get positive 1. Okay. What I want you to do is I want you to do the rest. Fill out the rest. Fill out the rest of the boxes using the exact same way we just did it. Okay? The exact same way we just did it. I want you guys to fill out the rest of those. So the area, so -1. So if I plug in -1, it would be from -1 to -1. So if the bounds are the same, area is always going to be 0. And then you have -1 to 0. From -1 to 0 is this guy right here, -1. And then from -1 to +1. From -1 to +1 is this guy here plus this guy here. So that would be -1.5. And then we keep adding. We keep adding we keep adding. So then -1 to 2 would be this guy, and this guy now. So that would be -3. And then you add in that last piece there to get to 3, and you get -5.5. One of the questions they're going to ask you is, what is the absolute maximum and minimum for G? From this interval. So this interval is -3 to +3. For the interval -3 to +3, where would the absolute maximum be for G? What would the absolute maximum be for G? Or minimum? What would the absolute maximum or minimum be? Say again. Not 2. At -2. It would be at -2. Why would it be? Why would the absolute maximum be at -2? Because the y value is the highest number. It's got the biggest y value. What would the absolute minimum be from -3 to +3? Because the y value is the smallest or the lowest, right? Okay. So it's easy to see when you have a table. So anytime they ask you to do absolute maximums or absolute minimums, always give a table because it's easy to see once you have a table. Okay. Okay. So I don't know if we're going to get to B because we got to kind of rethink all this stuff. How in the world do we find increasing, decreasing? So I have some questions. You have the answers, but you might not remember them. We have to reassess. We haven't had to deal with these guys since last semester. Last time we saw these guys was last semester. Relative maximum, minimum, increasing, decreasing, concave up, concave down, points of inflection, absolute. We talked about the last one, right? Absolute maximum minimums, make a table. But the first 4, how do we find those? What did we do last semester? Because it's going to be the same way. There's no new rules to find these guys. It's the same rules we used last semester. How in the world did we find a maximum or minimum? Because unless we remember that, we're never going to be able to answer the next question, because the next question is about increasing or decreasing. How do we know when the function's increasing or decreasing if we don't even know how to tell? The lucky thing is we've done this before. We've done all this before. I've asked you questions on tests, quizzes, homeworks, practices about all of these things. So we have to kind of draw on that. Yeah, it involves a switch, involves some switching. Something about negative to positive or positive to negative. What was it? You're right. What changed? What switched? No. Increasing and increasing was where something was positive, and decreasing is where something was negative. Same thing with concave up and concave down. What did we, instead of slope, we said, we didn't use the slope, you're right, but what did we say was we used a different word. Started with D, derivative, right? So for increasing and decreasing, we said where the derivative, F's derivative, we'll just call it F, was positive, right? Decreasing is where F's derivative was negative, right? Okay. So now let's go back to relative maximum and minimums, because these are related. When do we have a maximum? You guys said when something switches. What switches? There you go. When F, so maximum is when F prime switches from positive to negative. And minimum is when F prime switches from negative to positive. This is all in your notes. This is all in your notes, but it's buried in there. Okay? So all of this stuff here is not new. It's just it's notes from previous stuff. Okay? Those are all the first derivative ones. How do we do concave up or concave down or points of inflection? What was the concave up, concave down, points of inflection? Not the y value. What was the difference between maximum, minimums, increasing, decreasing, and concave up, concave down, points of inflection? Second derivative, yeah. So the second derivative is positive for concave up. Second derivative is negative for concave down. Points of inflection are the same thing as points of inflection are change of direction. When F double prime of X switches signs. Right? From positive to negative or negative to positive when it switches signs. Like I said, all of this stuff is review. We've done this before. It's in your notes. We've taken time to actually write all this stuff down. So if you're not sure on it, go back to your notes. It's in there. That's where the second part of the fundamental theorem uses this stuff. So now we're going to see these questions again. Okay. And then we did absolute maximum minimums, right? Make a table. Whatever the biggest value is or the smallest value is, absolute maximum minimums. Okay. So the first question on your notes says increasing, decreasing, right? I believe it does. Increasing, decreasing. Yes. Where are the intervals of G increasing or decreasing? So they're asking us about G. How do we know? How do we know when G is increasing or decreasing? Don't even worry about the picture. Don't even worry about the picture yet. We'll deal with the picture. I'm more concerned with how do I know what to look for so that I can do it on any picture. When G prime is positive or negative. That's what we're looking for. That's what we're looking for. Okay, so let's go back to the notes. So let's write this down. G prime positive, G prime negative. That's going to be our justifications. G prime positive, G prime negative. What the heck is G prime? We know what G is, right? That's how we found all of these numbers here. What would G prime be? What is G prime the same as? The graph, yeah. It's the same as the graph. It's the same as the graph. G prime is the graph. That's G prime right here. That's what the second fundamental theorem says. Without the second fundamental theorem, we wouldn't know that. This area under the curves represent G. Derivative of that is this graph. What would the derivative of that be? What would G double prime be? We'll get to that. Well, I don't want to get there yet. Well, we'll get there. We'll get there. Okay. So G of t, G prime of t is equal to the graph. So when is the graph positive or negative? When do I know when the graph is positive or negative? There you go. Above or below the x-axis, right? So let's write this down. Above or below x-axis. That's where we look. Again, that part is written in your notes, word for word. I looked it up the other day. It's in there when we were talking about this graph part for derivatives. That's in there. Okay? So, increasing. Well, let's see. From -3 to -2, it's above the x-axis, right? Anywhere else? Doesn't look like it, right? And then we have to justify. Because G prime of x is positive. Decreasing. Well, it starts decreasing at -2. And then at 0, it becomes 0. So I've seen it both ways. I've seen some people just say from -2 to +3. I've also seen some people say from -2 to 0, because technically at 0, it's not negative or positive, it's 0. So either one is okay. So I would say from -2 to 0, or from 0 to 3. Because technically at 0, it's not negative or positive, it's 0. And then we're going to say because G prime of x is less than 0. Okay. All right. That's where we're going to stop for today. But that's what we're going to, the next question you can see is concave up, concave down, relative maximum minimums, those kind of things. Okay.